Good afternoon, everyone. I welcome you to session 2 of PDP on AI meets signal processing, a practical PDP on MATLAB tools and techniques. In this session, we will be understanding about deep learning workflow. We will be creating and training deep learning networks using Deep Neural Designer app. We will also be learning about transfer learning approach. So without further ado, I'll request Kunal sir to please begin the session.
Yeah, thank
Over
you,
to you,
ma'am.
Kunal sir.
Thank you, ma'am. Dear participants, I hope you might have received an access to the PowerPoint slide. If not, just let me know. And I hope that once we have this, we should be able to follow that what I've been doing, right? Just to tell you that what are the certification courses that you should do later on. Uh, Today you can complete this task, that is deep learning on ramp course. This is a 2 hours course. I will share the link with you. So if I go to my home and I look at on ramps, or if I look at learning path, so let's click on learning path. Okay, so you can complete this deep learning techniques in MATLAB for image application. Okay, depends upon you, how you need to take this ahead. So I am sharing 2 links with you, one for an on-ramp course. Okay, you can use this link. And if you all feel like you want to further get a certification from MathWorks, you can go to this learning path, and I'll request you to complete this deep learning techniques in MATLAB for image applications. Okay, tomorrow, when we will go and we'll find out, doing things into detail, working with ECG data, you can go ahead and you can complete this. Okay, most of the things that I'll be talking about will be around this course. So there are 2 links. I hope this is fine with you, right? Okay.
Yes, sir.
Yeah. So I was talking about audio feature extractors. And since I've already shared slide deck with you, you can go through it and you can just find out how we are supposed to move ahead. Fine. Now, let me go to MATLAB. Click on open in MATLAB online. You can use offline version, you can use online version, doesn't matter. See, I have my MATLAB offline version. And if you remember, I can use this up down arrow key to understand that what were the codes that we have executed, right? Okay. So I am using this code. I have already shared a link with you for this particular example. So this was the first link, which is already there in your group, right? Okay. So what I was discussing previously, if we are supposed to, okay. If we are supposed to extract the features, which features we will be extracting it and how to do that. So you can say that I am a researcher or a scholar, and I have to work with building AI application for signal processing. And the most common task that I do is to extract features from the audio signals or general signals. And then you can think of, okay, are you going to take ML approach or are you going to take deep learning approach? And then can we automate this process? Now to help you out, if you go to MATLAB live script, under live editor in task, you will get a task for extract audio features. In extract audio features, we need to use two inputs. One is audio in. So this is a data sample. Another one is the sampling frequency fs. Now how I am going to get this two, audio in and fs. So let me go back to my MATLAB. I'll copy this part, Control C. I'll go to new and I'll take a live script. Control V. Let me remove this semicolon and type who. And let's try and execute this section. So when I use this variable who, I understand that there are two, when I use this command who, I understood that there are two variables in the workspace window, audio data and fs. And that was what we actually required. Let me put semicolon back. Wonderful. I'm able even to play this audio. Now let me add a section break. So if you're following me, just let me know, right? You can go to live editor, you can go to task, and I will search for audio. This will be a very fun exercise, so please try and do this also at your end. Right? If you are able to find this, click on extract audio features. Task. So I am zooming in, zooming out so that you get a better view of it. Okay. Now you see, I have already got the variable audio data and fs, if you can see now. What I'll do is select audio data, select the sample frequency fs. As soon as I do this, let me rearrange the things. As soon as I do this, the other options are enabled for me. What are the options? Which window you're going to use over here? As already DSP, digital signal processing, might have used Hamming filter, Kessier filter, rectangular Chebyshev filter for you. I'm using it to be Hamming window. I am keeping it to be default. What is next? Next, I want the features. Which features are you interested in? Which features are you interested in? So we had discussed, if you remember. Okay, let's go back to our presentation. Do you remember this features? We had discussed about these features, right? Let me click on, like I need first linear spectrum. Let's click on the linear spectrum. As soon as you click on linear okay, just a second. What has happened is like the two section has merged. Okay, fine. Now, as soon as you click on linear spectrum, if you see, I have not clicked on any of the options, display result or something like that. So what I will do is first plot the audio. Let's see like how the audio signal looks like and how it gets plotted. I have told you like you can directly use the command plot t comma audio data over here, and you should be able to plot the audio. So see, this is how the audio signal looks like. I hope this was pretty easy for you how to plot the audio signal. Any issues, any challenges? If there are, please let me know. I would be happy to help you out. Any challenges? I hope there are no challenges.
No, sir.
Let us back to MATLAB. Like we have already plotted this, right? Now we are interested in, like we have selected the linear spectrum, MEL spectrum, Bach spectrum, ERB spectrum. What is next that I can do? You can click on plot features. Since I've already selected this linear spectrum, you will find out that I am able to get a plot of this. So see how easy this was, or how easy this is to generate an linear spectrum. Fine. And you can see that the representation is in time and frequency. I will also like to draw your focus on this. So let me copy this, copy as an image. Let me take a new slide over here. Okay, I have got this figure. So see how easy it is to copy paste the figures. Okay, when you're working with MATLAB. And let me even copy this figure. Really sorry. Copy as an image. Control V. Let me align the figures so that I may be able to help you out in pointing the things that actually I want to discuss about. Okay. Now, I hope you are able to see this part, the discrete Fourier transform. Can you observe this? Corresponding to this, you may find a patch over here in this region. Similarly, if I take another segment, I use black color, okay, other segment. So this is the segment that actually I am interested in. Corresponding to this segment, you can look at this window. So when you look at the linear spectrogram, you will find out that with respect to this color bar, okay, which is power dB, it actually tries to show you some information for this segments. I hope this is clear to you. Right? Okay. Now, I want to plot other features also. So let me close this figure. And someone will say, okay, in the slides you mentioned that you can have MFCC, MEL spectrogram, Bach spectrogram. So if I click on MEL spectrogram, say this is auto to run. And we are now expecting the figure to update. So we will find out over here even MEL spectrogram is added, right? Are you able to observe the difference between linear spectrum and MEL spectrum? If you are unable to recall, see, we discussed over here like how basic spectrogram and MEL spectrogram may be helpful, right? So when you are working with a speech signal, MEL spectrogram or a bar spectrogram can give you a better representation. Okay, I want to add bar spectrogram. You can add it. Let us wait for the figure to update. Now you can see I have got MEL spectrogram, Bach spectrogram, and linear spectrum. If you zoom in, like if I zoom in at this time t is equal to 1 second, what I'm able to see, it gets very well represented, okay, in MEL spectrogram and Bach spectrogram. Fine. What about MFCC and GTCC? Let's click on MFCC. I don't need linear spectrogram. You know why? Because I think the other presentations are giving me, I'm getting a better representation of features in other techniques compared to this. Okay, let me remove linear spectrum. So if I can represent this speech signal in the form of MEL spectrogram or a bar spectrum or a MFCC spectrum as an image, because this is into time and frequency. For MFCC, this is time coefficient. I can apply convolutional neural network over here. Fine. But there are other spectral descriptors. What are these descriptors? So let me uncheck everything. Okay. I do not need this. Let me uncheck everything. So I have only audio. I am interested in the spectral descriptors. So we'll do one thing. We'll click on output summary as well. And we'll click on Centroid. So see, this is the plotting the centroid of this particular speech signal. What about other descriptors? So let me click all. I want all the descriptors, okay? So, okay, the figure is still updating, so I will wait. Now see, I have got all the figures. It's easy for me to save this figure. Okay, I can just go and save the figure. Okay, and what you might be able to see that I have got all the descriptors. Don't worry about this. Okay, we are only interested in that if someone asks you that if you have got a speech signal and you want to extract features from those speech signals and you are looking for some spectral features, what this could be. So this could be entropy with respect to time. This could be, let us suppose, kurtosis with respect to time, skewness, spread with respect to time. So you can take only those descriptors that you are interested in. But if you scroll down, see, I'll tell you one thing. You can see there is an output column mapping. So what is an output column mapping? It is telling you, okay, what is figure 1, 2, 3, and so on. So, you know, here I have 11 such descriptors. Also, with the help of this output column mapping, this particular task, whenever we apply or we click on any instructions, any checkboxes over here, what we are extracting features. So now if I type this command who, see, it tells me that I have got features also. Now what is there inside these features? So if I do this size of features, what do I get? I get there are 76 rows and there are 11 columns. So you can see 11, the descriptors are 11, right? Let's double click into features. In the workspace window, go to features. Okay, and then you can see this is my feature map, feature table. So now you can save this feature table. You can save the feature table and you can go ahead. Okay. Now someone may say, I am looking for a code. I am looking for a code. You can click over here and it also shows you the code. So here what we are doing, we are using this audio feature extractor, sampling frequencies fs. Wherever you see true, that are the features that I want to extract. So if I replace true by false, or let me uncheck over here. So I don't want flux. So in my code, the flux part, okay. In my code, that particular part will be false. Or you don't mention it over there. Fine. And then later on you can plot all extractors and all the features. Okay, please let me know, dear participants, are there any challenge? Fine. Let's move ahead. Okay. Let us come to a very interesting part. So if someone says that, you know, we understood that there is an audio feature extraction object which can be used to create a feature extraction pipeline based upon the features you select, right? So how can we look at this? So look at the block. So inside the block you have input. So I am writing this as step 1. This is input. Step 2, you mention the windowing technique that you want to use. Now from this, you can extract certain features. Now what are the features? So this is step number 2. So if I try to group the features, okay, spectrums. So this is my features. I'm writing this as feature 1. They are into one group. Over here, feature 2, they are into second group, let us suppose. Feature 3. Feature 4. And at the end, you can comply, you can, you can see that, you can check whether you have been able to complete all the pipelining part, so that at the end, what you get output. So output is nothing but the feature table. Now let's try to understand an exercise. Next. You have been given a task, and what is the task? The task is you have been given a speech signal. They are asking you that I need a Bach spectrum, and for this Bach spectrum I need centroid and flusk. I also need pitch, harmonic ratio, and then I need delta delta of the MFC. I will write a code for this. So code is shown to you. So this is the question that has been given to you. So we take this audio feature extractor, the spectral descriptor that we want is Bach spectrum. See, centroid is true, flux is true, pitch is true, harmonic ratio is true, MFCC delta delta is true. If you omit other features, or if you take a feature and write false in front of it, that would not be considered. Right? Okay. This is the output. So if you look at the output, you will find it over here. It gives you the first block, that is properties, and tells you what windowing technique or whatever you have used. Next, it tells you that the spectral descriptor input that you are selected the Bach spectrum. The number of enabled features are mentioned over here. Next, you have the disabled features. And then you get a note over here. And what is a note? There is a note that to extract a feature, set the corresponding property to true. This particular part. And the pipeline is shown on the right hand side. Okay, let's move ahead and let's come to the important part, because we would be starting with this examples. Okay, and then we'll move ahead. Now, what we have seen that there is an audio signal or a speech signal or a signal from sensor, signal you have generated. You can extract the features. You can label the features. You can label the data. You can extract the features. And now, once you know how to build up the pipeline for audio feature extraction, you're going ahead and you are selecting which neural network we should use. If you remember, during our first session, today's session, session 3, we have discussed upon two approaches. The first approach was to build your neural network from scratch, and other network was to use, in the other network we wish to use pre-trained model. And I had shown you that there are several pre-trained models. Which are these pre-trained models? YMNet, Vijajish, OpenL3, Creepy, and VetNet. These are audio pre-trained network. These are audio pre-trained network. These are not image pre-trained network. Let me tell you. There's a difference between image pre-trained network and audio pre-trained network. If we decide we want to use any one of the audio pre-trained network, They're telling us that you have a pre-processing and a post-processing function. So for YMNet, this function is known as YMNet pre-process, which is pre-process, OpenL3 pre-process, Creepy pre-process, Creepy post-process, WedNet pre-process, WedNet pro-process, and so on. And then it also tell you how you can classify it. Next. I'll move ahead. Okay, transfer learning with workflow. Now for this, I will go to my MATLAB. I will go to, okay, I want to complete this deep learning on RAM course, let us suppose. And I want to utilize this to teach you, the concept of pre-trained model and this sort of things. If you want, you can do this side by side so that we will be able to cover at least some part of this course, because I want to teach you the concept of pre-trained network, and then we will slowly move ahead and we'll try to see how we can use this for audios also. Now, I'll go to introduction and I'll click on start module. And you might have observed one thing over here. It's telling you that this version of the course is out of date. Use the latest version. Fine. Let's click on this. Use latest version. Let's start. Okay, so once you have seen what is the preliminary thing about right? You can see now in this particular figure that there are layers. Okay, we'll be talking about this. So what I'll do is I'll just help you. Okay. And we will try to cover this course. So see, what we are going to do is we are going to use this pre-trained network. So I'm covering the part of pre-trained network over here. Okay. Click on next. So in this section, what we are going to use is we are going to use a pre-trained deep learning network to classify the contents of the images. Okay, so here you can see that the labels or classes for this networks would be like beach, cat, cupcakes, fish, keyboard, pen, and so on. Fine. But the first thing is we need to read the image. So it says that you can use the IMRead function to read the images. If you remember, we have used audio read function to read audio files earlier. Files may be in the form of GIF, JPEG, PNG. Let me copy this syntax. I is equal to IMRead. It's saying that import the JPEG file. So the file name is file01. And it is telling me that this file is JPG. So I will type the instruction JPG. The image is to be stored in the variable img1. So I will write img1. Now see, if I execute this, I am going to, okay, I will remove semicolon first. I want to show you something. Are you able to look at this output? 90, 91, it shows you colon, colon 1, then it will show you colon, colon 2 and so on, and colon, colon 3. Remember what are this? These are the pixel intensity values. Look at the size of the image. The size of the image is what? 227, 2273. Let me click on semicolon. So here 1, 2, 3, colon, colon 1. So it's all rows, all columns 1. Let's click on submit. So I have been able to successfully read the image. In next task, I have to visualize the image that we have read in the earlier task. So here I can type imshow I. And you can see that it's giving me an error. You know why it's giving me an error? It's giving me an error because the variable in which my image is being read is img1. Right? So I should write over here img1. Submit. So this is an image. So there is a tree, there are hills. I think it should be a seashore or something like that, okay? But I don't know what the class is. Let's go to next task. My audio is too low. Just a second. So this is about a pre-trained model. We are just trying to understand how the pre-trained model looks like, okay? And how this can be useful for us. Please take a good look at this. Okay, once this is being done, let's move ahead and let's complete the task. You can see over here what is it is saying me. It is saying me that you can load the image pre-trained network. And how you can load the image pre-trained network? So here they have given us the sample of it. So this is the syntax or instruction, the sample code for us, let us suppose. And now what we are trying to do is we are trying to use QuizNet. So this is CNN model, okay? QuizNet. Fine. So this is task one. What I want to do is I want to use this net is equal to image pre-trained network. Let's first try to click and let's see if we are able to do this. If it gives an error, then we need to look over there how to use this. It doesn't give me an error, right? It tells me that when you load a pre-trained model, it has layers, it has connections, it has all other information. Let us submit this and try to see if we have been able to do this correctly. Click on next. Now we need to classify this image. So we need to find out what this image is talking about. So let's take an example that there is a drone and this is a spy drone. So spy drone tries to capture an image and you receive this image through a satellite network. Are you going to manually classify what it is talking about, what the image share talks about? It could be an airstrip, land strip, sorry, airstrip in the sense like it could be a strip from where the aircrafts could fly. It could be a picture or photo from a sea where you see there is a submarine or a warship. Deployment of troops. Are we going to manually classify it? No. So we'll use a syntax. What is the syntax? The syntax is over here. So we have been told that use the mini batch function with pre-trained network net to predict the subject of the image shown in the image one and save this in S. So I can write over here S is equal to mini batch predict. And here it requires net and it requires the image that I want to classify. Let's first see are we getting in here before we submit it. You can see I've got the scores. You can look over here, scores. Now what is the size? The size is 1 by 1000. What do you mean by that? This every column represent a score for every one class. So you'll find out for few classes the score is 0. For a few classes the score value is 0.2, 0.002, 0.13 and so on, right? But the addition of all this 1000 scores should be 1. Now I want to find out, so if I do this, let us suppose max S, maximum score I want to find out. I'm doing this. So it says that the maximum score is 0.5923. I want the index number of this particular score because I cannot manually go and find it out. Okay, what is this? What is the score for score 0.592 and where it is located and for which class it is, right? Okay, but as I've told you, if you try to sum the scores, see what it tells you. It gives you 1. So the sum is 1. Okay, fine. Let's submit. Next. See, simply getting the score is of no use. I want the name of the class. So what I am supposed to do is, so in task 3, what I can do is, I can write this as net comma classes. Is equal to, now I'll put a square bracket to this. Let's run this. Can you observe now? I am getting the name of the classes. So what are the name of the class? The name of the class are shown over here: tench, goldfish, and so on. So there are total 1000 classes. We have seen earlier that one of the class is getting a maximum score of 0.53. I need to find out which class is this. Submit task 3. Let's go to the next task. Now, as we have already evaluated the score, max score, which is 0.53, I need to find out the name of the class, right, or label. For this, I'm going to use the function scores to label. So see, what I'm trying to do is, here it is, they have said that you use the variable C. So I'll take C is equal to, the function name is scores because I have calculated the scores, right? So it is score to label. The input is, see, I have already got the score in the variable S, and I have got the classes in the variable classes. So I'm talking about this variable S, and I'm talking about this variable classes. Let's try and understand if we are able to predict. So see, it tells you she sure. Let's click on submit and try to verify. This is correct. Let's move to next task, which is task number 5. Okay, what is task 5? Now, if you see, we have been also able to read file 02 and file 03. Looking at this, I can tell you, I'm not sure which is file 02 image, but it appears to be cat to me. And this appears to be couch or a sofa. But I don't know, like we will ask the pre-trained model to classify these images for us. Okay. Is it fine? Is it okay? Shall we move ahead then? Okay, fine. So what I'm supposed to do, see, I was calculating the score for image 1 using this instruction. So what I can do is I can copy this and I can write over here image 2, and to classify I can use this particular function. So since this is for second image, I am writing this to be S2 and this to be C2 as it is mentioned over here. Can I repeat this? Yes, I can repeat this. So let's repeat this for image 3. So I'll write this as image 3, S3 and C3. I don't know it is right or wrong. Depending upon what we have done, what earlier tasks we have done, I get to understand that, okay, this is how it should be done. Don't worry if we get it wrong, we have an hint option over here. We'll use that hint option. Okay, so C2 gives me that this is a toy terrier over here. So it identifies this is a toy instead of cat. Fine. What about the second image? Second image is studio couch. So you can put a semicolon for scores. And now you can run this. Okay, and see I've got the answers. Probably I'm not happy with this toy terrier. Okay. Submit. And you can click on next task. See, in task 6, if you remember, we have used this command net comma classes is equal to image pre-trained network. But there are many pre-trained networks for images as well as audio. And therefore, what we are supposed to do is, like when we do not specify which particular pre-trained network we are interested in, image pre-trained network, by default, it loads SWISNet. But if I explicitly specify that I want GoogleNet, so the changes that you're supposed to do in task 6 are add a round bracket and you should add GoogleNet. Run this and you should observe that the information for this variable net is changed. You can observe this information. Click on submit and let's try to see, have we been able to do this? Yes. Click on next task. If you wish you want to do further practice, you might do it, or you can go to other module. Look at the percentage. So we have been able to complete certain modules. Okay. We will complete these 2 modules. And if then we will decide if we want to go ahead. Okay. Let's click on this. So I had already covered this part, if you remember, but this was really helpful for us to get started ahead. Let's see the working of convolutional neural network. being done, if you go ahead, you can complete this course. We have already completed 19%. Okay. I have talked about the prediction course also. Like we get the score, and from the scores, we try to predict, okay, what is this class all about, right? Okay, and as you can see in this figure, there are three classes. Like you have a cake, car, a zebra, right? So the highest score is the class that it has been able to identify correctly. But in the first figure, you can clearly see that one of the class has higher score, while other two class has same score 0 and 0.1. If you look at second figure, you'll find out, okay, this is a close competition. One class is 0.4, other is 0.3, 0.3, the scores, right? Okay, so in this case, we can find out in the second case that model will try to misclassify certain objects. Fine. I will complete this particular module, and then what we'll do is we will try to stop, because there is not much difficult thing. Anyways, we all were supposed to complete this. So if I have, so this is a task wherein I need to plot the prediction score, a bar chart of the prediction score. How I can do that? So this is scores, right? If I type this bar of scores, it should generate a plot for me. And if you look at this plot, I am getting one peak value over here. So these are scores. So one is for 977, which is 0.05. And if I go over here, probably this should be 0.9. I don't know what it is. Okay, I need to click on this and get it. But the score is around 0.25 or something. What about other scores? So these scores are less than, even 0.1. Will be closer to 0, and that's the reason we are not able to see any vertical lines. Submit. Next. This pre-trained model is trained for 1,000 classes, so it can classify 1,000 classes. However, as we notice that the scores of many classes are 0, and therefore we should focus on only those classes, which has a significant score or a highest scores. This could be top 2 classes, top 3 classes, and so on. How to do that? So see, it is asking us, you create a logical array with the name high score. So I take over here high scores. You remember we have discussed about logical array. So high score is equal to scores which are greater than 0.01. That's what we want to do. I don't know this is right or wrong. You can go to hint button and you can say what it tells us. It tells us that, okay, use greater than sign or use greater than operator to compare scores and 0.01. I have done the same thing and I wish to store the result into high score. Click on submit. Let's see if we are right. Yes, we are right. We have been able to do that. Next. Now, I will type this bar scores I think it should be high score if I'm not wrong, because this should be high scores if I'm not wrong. Okay, let me type this. High scores IDX. Let me see if this is right. Okay, so can you see, I'm getting some error over here. All right, I'm getting some error over here. So what can I do? Can I go to hint? Yes. So it tells me, okay, you cannot do it like this. So what you're supposed to do is use high score logical array to index scores. Okay, so I can use scores and I can type over here high scores. And if you still feel like you are not able to get this correctly, you have an option over there, okay, wherein you can go and click on see solution. Next. It's asking me use logical indexing and the xtext label function to label the bar chart with the appropriate predicted class names. The full list of the name is stored in the classes variable. Okay. I think it's asking me to do this. XTICK LABLES, because see, I'm getting over here 1, 2, 3, 4. And I can write over here CLASSESS classes, and I can pass over here scores, high scores. Let's see if we are able to do this. Okay. See, I've got this wrong. Is the bar chart created properly? No. So you can click on hint. And okay, it's telling me there is no need for me to use this course. Okay. Let me see if and like I've told you, you can reset this, you can go to hint. And even if hint doesn't work for you, the last thing would be to click on see solution, right? But dear students, dear participants, I'll tell you, you should go for the hint only as a last option, okay? Don't use this. If not at the first case, okay? Click on next. So we'll look at this data store because I want to explain you the data store. And then we'll go to the next part, which is our audio data store. Fine. Now we have been able to complete 25% of this particular course. So whatever part was there, I have already tried to cover that particular part. So I'm skipping this particular part, the part to create the image data store. And I want you to take you to the module number 4 over here. That is what is transfer learning. And module number 5, we will try to cover, from our other examples. So go to module number 4. Okay, click on what is transfer learning. Now remember, what we are trying to do is we are trying to cover the course part, as well as we are trying to cover certain demos that are the shipped examples available with the MATLAB documentation. Let's try to understand what is transfer learning. Okay, so let's move ahead and let's complete the very, very essential part of deep learning. That is getting started with transfer learning. Let's start and let's try to complete this particular module. Now see why the modules are designed the way you can go and you can start anywhere the way you want. See, the reason is you may be an expert, you may not be an expert. You feel like, you need to practice some stuff. You can come back over here. You can go through these modules repeated number of times. And if you feel like you're not confident with one of the modules, you can come back again. You can start with whenever and wherever point you want. We'll complete this. So we are going to follow the same process even for audio. So the first thing is I have a directory and I have kept all my data into this directory. I will create image data store. So I have created the image data store by the function image data store, folder name, and whatever classes it has, subfolders. These are my class names. Right? Okay, fine. You can run this if you want, so that you know you are able to. Okay, let me run this folder. Fine. What is next? Okay. Now for this task, we will use the solution. Okay. So here you can see, let's copy this. And let's submit. Now the reason I have done this is because you might not be aware about the okay, let me see what is wrong. This okay. It should be FLRDS. My bad. So what we have created a data store over here, and if you see, I have got the list of the labels, right? And you can see over here it's mentioning categorical. Now I don't know how many such labels are there. So see, I will use this instruction unique flower names. Now do remember that when I'm doing this unique flower name, this is not a part of the task. Okay, this is just an additional information for you. So there are 5 labels. Let me remove this. So now I understood what are the labels. They are daisy, dandelion, roses, sunflower, and tulips. Next task. So we know where our data is. We have acquired the data set. We have created the data store. Now it's time to split the data into training and testing. We'll have a look at this. Okay. Now we need to split up the data. Now remember, why we split up the data? We need to split up data into training and testing. So the common thing, the common function that is over here that we use most of the time is split each label, right? Because there are 4 labels over here. And then we have over here, so if I use this, if you talk about this P, now this P is a value between 0 and 1. Now instead of IMDS, we can write over here FLWRDS, because this is the name of my image data store. So how am I going to change that? Okay. Now the 2 data store that I want to create are FLWR train, comma, I have over here FLWR test. It's equal to split each label. What's the name of my data store? So the name of my data store is comma, and since it's 60%, I need to specify 0.6. This is how the instruction looks like, okay, for task 1. You are preparing for some exams. You really don't know what will be the sequence number in the exams, right? You really don't know what will be the sequence number in the exams, right? So when you are applying the test, it would be a test with the known questions, but then the questions are random. And out of 100, you have been given only 80 questions. So you really don't know which is which question number, right? So that is what we are trying to do over here. Done. I had talked about this, if you remember. Balanced and unbalanced, right? This is important for you because if you go to real world scenarios, like tomorrow we'll be looking at a data set wherein in each category there are more number of samples compared to the other category. And therefore it is really important for us that first we balance the class, and then what we try to do is we try to go ahead. So what is task 3? The task 3 says that up till now you have splitted the data set with the splitting ratio. But if the data set is unbalanced, instead of specifying 0.8, can you specify and can you write this as 500? Go to hint and see what it tells you. It tells you that both the train and the test data set should have equal 500 files. That's what I've tried to do over here. I hope you might be getting some insights about this. Click on next section. Next, let's prepare the inputs for the CNN layers. See, we are very close to, okay, let me go to this, set the number of classes. We are very close to train or model, right? So now what we want to do is we want to use this task, and what this task says that you load a pre-trained network named GoogleNet. If you remember, we have already covered this, so I'll write GoogleNet. And it's telling us that you define the number of classes. If you remember, how many number of classes were there? There were 5 number of classes. As you can also see over here, daisy, dandelion, roses, sunflower, tulips. Submit. So that is how you load a pre-trained network, right? Next. Set the training options. There are 3 solvers. The first solver is already mentioned over here. Squaretic gradient descent with momentum, that is SGD. Then you have Adams, right? And RMS plot. What we are supposed to do is we are supposed to create a variable name, training options by variable OPTS. We need to use the function training options, and we need to specify over here what training options I am going to use. So this could be HJDM. Is this sufficient? No. We need to add few more training parameters over here before we actually go and train the model. Okay, I made a mistake. So this O is supposed to be capital, case sensitive. Next is the learning rate. What is the learning rate? So first let me write it down. Okay. You can see in options you have different other things to add. I am interested in the learning rate, right? Okay, so I can write over here initial learn rate is equal to, so the default is 0.01. I am taking it to be 0.001. What exactly is this learning rate? So see, learning rate actually defines that how your model is able to, okay, let me do one thing. Let me go to learning rate and I'll type MATLAB. I'll take you to the documentation. That will be easier for you to understand also. So see, if you type over here, you might find out different options are there, right? You have solver. These are the type of the thing, right? Now, if you see, we are yet to get this window, learn rate. Here you can see by default it is 0.01. The reason is it was not defined over here. It was not defined over here, right? So learning rate can be small or learning rate can be, or I can put it right like this, that learning rate could be fast or it could be slow, and this actually will determine, okay, how your model is able to learn the features. I'm putting it into very, very simple language, okay? Click on submit. Next task. And now we also want to add metrics, comma. We have options to choose. You can choose metrics and you can decide. There are so many things. You have accuracy, you have RMSE, F score, recall, precision, then you have MAP, mean absolute percentage error, L1, L2, mean square. So many matrices are there. Now, what we are interested in, we are interested in the accuracy for each epoch. Submit. Next task. Next. Now it's time for us to perform the training because we have set up everything. right? Now let's set up and let's train the model. You can see we have completed 54% of the course. Okay, fine. Putting everything together, data store, splitting of the images, resizing the images based upon the input layer, then taking Google Net, specifying the number of classes to be 5. OPT is equal to training options. We have image solver, matrix, verbose, frequency. Okay, and then what we have training over here, right? And you can look at the output. Let me run this, and you can actually look at the summary table. Okay, how the training takes place. So you can see over here there are a number of iterations. You can see that the training has started. And as discussed, we are interested in the training accuracy, right? So we should be able to see the training accuracy, whether it is increasing or decreasing, the training losses. And you may see that the initial learning rate over here is set up to be 0.01. Since it's not mentioned over here, it means it's a default value. Slowly you may observe that the accuracy is increasing. So you have number of epochs. So in the 5th or 6th epochs, you'll find out accuracy is almost close to 90%. Okay, so the model has trained. Let me check how many number of epochs. Oh, it's still running. Okay, the number of epochs by default should be 10 over here. 10, 30. We need to check. Okay, what is the default value for number of epochs? It should be 30 if I'm not wrong. Okay, so as we can see, we are in the 29 epoch and the accuracy is 100. Okay, training had stopped. We have reached the maximum epoch, and it could be seen that the accuracy is 100. Okay, let's go to next task. You can investigate the train network. So it's like, since the model has been trained on the training data set, if we have a test data set with us, okay, what we can do is we can go ahead and we can do it. Okay, you can investigate. Now I'm leaving this up to you. You can evaluate, you can improve the performance, and you can do other things, right? Let me return back to my presentation. So if you see, I have already covered a lot of things in transfer learning, right? So what we'll do is we will try to classify sound using YMNet. And for this, we are going to refer to the example. I am sharing this link with you. This is what we are going to work with, okay? So I am sharing the link with you. Let me explain you the code first. So we are not training any model right now. We are simply using the train model. So we have an audio over here, which is the train whistle. So we use the function audio read, step 1. This is my objective, okay? I want to achieve this. Classify sound using YMNet. Okay. So once you go for audio read, okay, you have sampling frequency and the sample data rate. I have told you how you can plot it. So once you go for audio read, the next step is to plot. So you plot the data, and I've told you it's really easy. You can either write a code or you can use task over there. What is next? If you remember the slides earlier, I have talked about certain pre-processing function. So if you're using YMNet, I need to use YMNet pre-process function. I want to use YMNet pre-process function to get scaleogram and spectrogram. Now what are scaleogram, spectrogram? If you remember, they are feature extraction. So in this case now is to get spectrogram, and to create spectrogram, what we are trying to do, we are trying to use the function YMNet preprocess. And can you see what are the inputs? The inputs are audio in and FS. Okay. Can you recall that in the feature extraction live task, we were getting different features extracted in terms of spectrum, if you talk about, with the help of FS, audio in, and can you remember windowing techniques? Okay. Anyways, male spectrogram, whatever which we have generated over here, okay, we will select any one of the spectrogram. We will go for the plot. So this is surf is a plot over here. I have discussed about this surf. Okay. We want spectrogram. You will set up the angle minus 90 degree to 90 degree. X label you have frame or Melbend, whatever you want. Y label frame, depends, okay, how you put it. This is 90 degree rotated. And then you have title and axis is title. What is next? If you think of image, it was fourth step is to classify. So we use this net.classes equal to image pre-trained network when we were discussing about images. Here we are talking about audio, so we are using audio pre-trained network. Right? Then we go for scores. We predict the scores and then we get the result. And what is the result? Whether it is able to classify the category, its whistle or not. This is easy, right? Once we know how to work with image, it's easy. Now, in this case, we have not gone for any pre-trained. What you can say, in this case, we're using only pre-trained model. We have not got ahead to set the hyperparameters and train the model for our own data set. We will do this later on. We'll go to MATLAB. Okay. We have over here this YMNet process. I've explained you this. Let me click on copy. Let me go to MATLAB. I'll just close the previous files. I will type clear comma CLC because I want to clear the environment as well as the command window. Control V so that I should be able to open this particular example. Wonderful. Let me right click and click on clear all output. Now see, I have different audio signals, audio signal if you want. Fine. Do you anyone remember how to use? Okay, let me put a section break. And if my Copilot is working. Let me check this. Help on sound SC. Let me check. Okay, I don't know, like sound. So I was able to play this. Okay, this is whistle, we all know. What is next? Any of the signal, just clear all output. Okay. And if you want, you can take this jet airplane also. So let me explain the code. Now why we are able to, what you can say, hear the audio twice. The reason is there was already sound written over here, and that was the reason we were able to hear it twice. But anyways, let us select train whistle. Right. Now you can also see the spectrogram which is plotted. Now, if you try to compare both the figures, okay, I have a figure over here, and I have, where is this figure? Okay, I think I closed it. Let me check if I closed it or not. Okay. Fine, it's anyway. Now see, if I try to overlap this, you can observe where there is a gap, there is blue color patch. Remaining part, you have this yellow color, some greenish color over here. Right? This is indicating some type of, amplitude presence. Anyways, if you want to use YMNet neural network, see what it does. It's telling you that, we are unable to access the pre-trained model. Make sure the files are installed, downloaded and unzip the zip file to the location on the MATLAB path. So you can click on this, the zip file. There's a hyperlink over here. So what we've been able to do is we got this pre-trained model. I will say Control X. I'll go to MATLAB, Home, Layout, Control V. Okay, right click, and I need to unzip it. Okay, so I'll copy this path. Go to Downloads, Control V. I'll extract this, close, okay. It's extracted, right? Can you see this? So I have this. Shift delete. I'll say add to path. Now let's try and do this. So see, I downloaded this pre-trained model, right? I am using this function audio pre-train. If I look at the scores, so let me remove the semicolons first. Can you see I've got the scores? And you would say, oh, I am unable to understand what exactly is happening over here, right? See, this particular score may be for different patches, right? So we can simply do one thing. If you go to my sound is equal to mode classes, so it will give you whistle, because for different segments it does identify, okay, it's whistle. So I have taken mode and then it shows me, okay, the class is whistle. Now if you want to do this, so if I change this and I take it to jet airplane, so look over here how the spectrogram have got changed. And if we know that this is for jet plane, but the YMNet model has identified the class to be vehicle. Okay, so before I take a break of 5 minutes, so we will take up to 4:20. Okay. I will not extend much. I'll explain you about Vijajish, and then we'll take the last example for this. Okay, YMNet, and then we'll stop. Okay, let me explain you Vijajish. So we have seen everything about YMNet. What about Vijajish? Vijajish is also a pre-trained model, right? So what is step number 1? Read the audio signal, plot the signal. Step number 2, use this Vijajish pre-process and get the spectrogram. This is how the spectrogram looks like. What is next? The next is to use this function net is equal to audio pre-trained networks and classify, and then it should give us an output, right? Okay, that is what is Vijajish net. Fine. Let me start with this example, because this is what we all are going to do, and then we'll conclude. Okay, Control C. I am sharing this link with you. So while I take a break of 5 minutes, I request you to please go through this. This is an example that we are supposed to do. Okay, fine. I'll be right back.
अजून पाव पडलं भाजी पडलं का काय झालं मला कॉफी आणून देणार शांत बस रे
मयूर मयूर सोना धागा रूठा रंग तेरा रूठा कैसे मिलाऊं
Hello, Sumit. Hello, you have a doubt, Sumit? Module, yeah, deep learning you can complete. Any doubts in the deep learning module, because we have also completed here. Any student has a doubt? I'm just sharing the screen. Yeah, once you complete the deep learning on-ramp Pro, you will get this kind of certificate of 100% completion. Similarly, deep learning and machine learning, the two courses are compulsory. which you will be asked for uploading. And extra other courses, all the students are free. If even if you'll do it, I'll add an extra question where you can upload other certificates also, apart from deep learning and machine learning.
Okay, ma'am, shall I continue? We'll take 10 more minutes and I'll finish this particular part.
Yes, sir.
So that from tomorrow we can work with biomedical signal. Okay. Fine. Now see, what we are trying to do is we are trying to work with this example wherein we are using a pre-trained model, audio pre-trained model. Tomorrow, like what I believe is you should complete that deep learning on-ramp today itself, so you get a better understanding of CNN model. And tomorrow I will show you that how you can use CNN models with audio signals. Right? Okay. I'll explain you the code first. Code is pretty simple. You download a data set which is known as a compressor data set. I already have downloaded this data set. Okay. Next, you create an audio data store. You find out number of classes, and this classes should be categorical. Next, we split up our data set into training, validation, and test. So the percentage is 0.7, 0.2, and 0.1. Now, these are raw signals, right? And we decided that we should use, and if you've decided that we are going to use YMNet, then YMNet requires an audio preprocess function. That is YMNet preprocess. Therefore, you will find out in line number 7, 8, and 9, for each of the data set, train, validation, and test, you have over here transform the raw train data set using audio preprocess function. So what is audio preprocess function? If you scroll down, you will find out that there is an audio preprocess function. Can you see? And inside this audio preprocess function, we are trying to use YMNet preprocess, which is actually returning a spectrogram. I hope this is easy for you to understand. And the best thing about MATLAB is, see, you also have got a reference paper over here, which actually tells you that if you read this reference paper, you'll find out, okay, that this is the approach that they have taken. Returning back, once you know how to create the spectrograms, you will download YMNet model. If it's not on path, we will look at the model. We will change few layers. We will set the training operations. We will train the network. We'll observe the result. We'll check the accuracy. And later on, if you want to plot, you can plot confusion matrix. As you're going to do deep learning part, they are going to explain it to you, right? Okay, fine. Let me remove few of the semicolons. So the downloading has started. It may take couple of minutes to download the data, okay? So let's wait by the time the data is downloaded. So what you can do to suggest your project, you can take your mobile phone, you can collect different sound coming from electronic equipments like motors, compressors, engine, train. Even you can do this for birds, right? Or different animals, depends upon you. And you can follow the same approach. I can see that the data set has been downloaded. How I'm able to see? You can look on the strip. There is a block of this black color, right? Fine. Now see, it tells me that there are 1, 2, 3 plus 1797, 2000 samples. What is an extension? .wav. See, you can use sound SC. You can read any one of the signal using audio read, and you can play the sound. Okay, fine. So, and what formats it supports that are mentioned over here. I wanted to look at the categories. So there are 8 categories. Bearing. So the noise coming for bearing, flywheel, healthy. Okay, this is input, output valve, NRV valve, piston, and riddle belt. What exactly this is? This is a big pump. Now, maintenance of the pump is very critical. So someone can understand, okay, like, you know, if you are using, if you drive 4-wheeler or 2-wheeler, your own vehicle, and there is something wrong with your engine, you'll find out there are different kind of noise that are coming out, different type of sounds that are produced. So if you go to mechanic, the mechanic, if he is an experienced mechanic, he has got skills, he will ask you to crank your vehicle, will hear the voice and will let you know, okay, this could be the situation of the vehicle, this part would be faulty. You need to replace that part, right? But for a pump which have so many components, it would be difficult, right? So what was being done? Some audio samples are collected for different faults, right? We got the data set splitted into train, validation, test. We have transformed it, right? What is next? Next is to launch the Deep Network Designer app. I'll tell you, either you can click on this blue color strip or go to apps, click to expand this section, click on Deep Network Designer app. Let's wait for the app to launch. The app is being launched. And since we are working with audios and a pre-trained audio data, I'll go to YMNet. So let's click on YMNet, open. Now see, it didn't ask me to install. You know why? Because I've already installed it. Right-clicked and I've added it to the MATLAB part. If not, then you may have to install it, okay? You may have to install it before you do this. Wonderful. How does a model looks like? So this is a layer diagram of this CNN model. You can look at the different layers. Click on input layer. You can observe what is the size, 96 by 64. Remember this. So if you are using YMNet and you have a raw signal and you represent raw signal into spectrogram and then try to save it as an image, its size should be 96 by 64. Remember this. Next, if you go to the tutorial, they will tell you that if you want to prepare a network for transfer learning, you need to find out the last learnable layer. That is, you need to find out this fully connected layer. Now, where is this fully connected layer? The last learnable layer. Scroll down. I can see this is the last layer, fully connected layer. How many classes do I have over here? 8 classes, as you can see. If you go to this, you can see the output size is set to 5 to 1. No, this is wrong, right? So I need to change this. Click on unlock layer, unlock anyway. You can keep the output size to be 8. See, there are other parameters like weight learn rate factor and bias learn rate factor. What are they? I'll tell you. Now, this pre-trained model has been earlier trained on some other data set. Now you have got a newer data set, right? That's the reason what we try to do, just to support our training, to get a better productive result from a training. We are setting the weight learn factor and the learn rate factor to be 10. Now, once this is being done, we have set up everything accordingly. It's time for us to click on analyze. So this will help us in understanding, are the layers connected in order? I should get 0 errors. Yes, I've got 0 errors. I'm happy for that. Next, I want to export the model. So click on export, export the model, and it is asking us, okay, try to save the model by a particular name. If you go to a tutorial, see, when you export it, it is saying that the default name by which it would be exported is net_1. If you want to change this, see, you can change this and you can write your own name. It doesn't matter, right? Click on OK. The model has been saved to the workspace. See, if you do not have Deep Network Designer app, you will have to do this programmatically. Tomorrow we'll see how to do this programmatically. Scroll down. Now set the training parameter. So in the training parameter, the solvers I have taken is Adam. You can take SGDM, you can take RMS prop. Initial learn rate, okay, it is 0.001, so it's slow. 0.01 is fast. Okay, the number of epochs are 3. Okay, if you keep verbose equal to 0, it won't print a table for you. So I will keep verbose equal to 1. Set the training options. The training options are set. Now it's time you train the model. See, if you want to add metrics, you can add the metrics. So if you want to add accuracy, you can add the accuracy. How you do this? So if I click on this and I say metrics, I want accuracy also. I've added accuracy, which was not a part of the original code. Let's rerun the section again. And now it's time for me to train the network. So we'll use the function trainNet. We are using training data set. We have taken the model net_1, that is YMNet, that has been modified at the fully connected layer as per our data set. The loss function is cross entropy, and here we have used the training options. Okay, let's wait for some time, because see, you may have a limited memory. For example, you have only 8 GBs of RAM. You doesn't have a GPU, and if your data set is too large, either the training may be very slow, or you may also get an error. Okay, the training may be slow, or you may get an error. And then you need to come back again and you need to modify certain parameters like mini batch size and all that. You can see I have got the table, and slowly I could also witness the training progress. So the training progress is showing me 2 charts. The charts are accuracy and loss. I want to see that the accuracy reaches to be highest. At the same time, you can see that the loss should be minimized with each and every epoch. Did you notice one thing? Here, the hardware resource is single GPU. In the training option, we had not specified what hardware it should choose. But MATLAB has got a parallel computing toolbox. And in the parallel computing toolbox, with the help of parallel computing toolbox, it tries to understand if there is a best resource, hardware resource available, which can be used for training the model. Yes, it has identified that there is a GPU. So I have a GPU of 4 GB. That's what we are using right now. Okay, one can observe looking at the chart and looking at the table, right? You also see the table that within the second epoch, we are able to get a better accuracy. The accuracy is almost 95%. We are still left with one more epoch. We'll allow the model to be trained. Okay, so I think we are able to reach to 99% under the third epoch. Now, someone can say that if I am able to reach up to 95%, I don't want to move ahead. Is there an option for early stoppage? Yes, there is an option for early stoppage. I do not want to introduce you that particular functionality at this moment, but yes, if someone really feels you want to choose that approach, please let me know. I could see a pretty decent curve over here. Let's wait for some more time so that all the iterations are completed, right? Okay. Okay, so training stopped, maximum epoch completed. Accuracy is 99.556. I have got the results saved over here. Now it's time for me to test the network. So see, we use this mini batch predict function. It will give us scores. You convert scores to labels, right? And let's check the accuracy. I have 2000 files, okay? So it may take some time to compute. Accuracy is 0.9946. And now I am leaving it up to you to add a confusion matrix. Okay? So if you complete your deep learning on-ramp course, you will be able to see how to plot a confusion matrix over there, right? Okay, just to end with, tomorrow, okay, so what we have done up till now, I'll tell you. We have used pre-trained model, right? YMNet or something like that. Tomorrow, we are going to use CNN model and LSTM models over here. So this is how the confusion matrix look like, the one on the right hand side. Okay, so I think let's stop. Let's meet tomorrow, okay, with the practical case study for the heartbeat classification, where we'll cover the machine learning part as well as the deep learning part. Ma'am, that's all from my side. I think we can conclude.
Yes, thank you so much for the session, sir. It was very informative and insightful. See you tomorrow. Thank you.
Thank you.